Hello everyone and welcome for another Python fundamentals course. Today we will be talking about sets. Alright, sets are a different type of container type, and I've already posted kind of what makes them unique. So one of the things that's unique about a set is that a set is unique, and duplicate elements are not allowed. So for list and for what was the other type, just the tuples, you can have multiples of the same object. Like it would just be indexed differently. So I can say Michael and then John, then Michael. So I'll have Michael at index 0 and Michael at index 2 as well. In a set, if you even try to make a duplicate, it would just not add it. It's only going to keep one. So one thing good about sets, if I was trying to do some type of data integrity check, or say I had different categories of data, I might actually create a set of the expected categories and then map it to the data to see does it return anything that's not in the set. So sets are kind of used for integrity checks. Sets also is used for like say you have multiple teams, and that's the example I'm going to use. So you have multiple teams and you have members or people in classes, and you're taking different classes, and some of the people are in the same classes, and you want to see which students have the same who are in both classes, or which students are only in class 1 and not in class 2. Sets are able to do those type of operations as well. So if you're familiar with Venn diagrams, sets are ways to break down the different elements of the Venn diagram by looking at the union, the symmetry differences, looking at the intersection, which is like what data that's in both, and I'm gonna talk about those in this video or the next one behind it. But we'll spend a little good time on sets, just to make sure you truly grasp the concept. So let's get it. Let's get started, and here we go. All right, again, sets by definition are unordered, unindexable collections. So when we try to do that, we won't be able to. Unique, no duplicates. Sets are immutable. Oh yeah, I didn't say that. You can't change a set. Like what's in there can't be changed. Like I can assign it to nothing else, for one, because you can't index to it, therefore you can't assign. But the actual set itself, the instance of the set, like we make an instance, like create a variable and set it to an instance of the set, it can be changed. So you can add people, remove people, or add items and remove items and stuff like that. So that is true. All right. So let's start with, set creation. And for this one, I actually want to do team A, team B, because I actually believe when you look at teams in a set, it explains and do a really good job at kind of seeing it in a real world example of kind of how you would do sets. So what I'm going to do, I'm going to create 2 teams. I'm going to create a team A, which is going to consist of, and to create a set, let's create an empty one so you can see it. Set uses the parentheses, the squirrely parentheses, not regular parentheses. I ain't sure what its official name is. I call it squirrely parentheses. But it's the shift key with the bracket, that parentheses. So if you do shift enter, that's not right. I'm wrong. I think. No? Oh, it's interesting. I want to see something right quick. This what just happened I wasn't expecting. I want to see if I add a comma, does it change it? No, it doesn't know it. Oh, okay. So to create a set, I don't think you can, by default, the squirrely brackets creates a dictionary, which is what I'm going to talk about next time. But to create a set is the same way. I guess you actually have to put something in it. So I think to create a set, I think I'm starting to remember the rules. You have to have an item in it, and you have to have a comma. That comma tells Python that you want a set. So I'm going to take this and type my name, Michael, as part of team A, and put a comma after it, and then shift enter. Yes, that's what it is. I figured it out. All right, so if you put, this comma is important if you're creating a set of one item. So in general, you don't create sets with one item. So that's the problem. I was trying to, you don't normally create empty sets because usually you know what you want to go into each set, like set of items. But if you did want a set of one item, to do that, you just type in the item and then put a comma, and that'll let Python know that it wants to be a set instead of a dictionary. So what I did initially was create a dictionary, empty dictionary. All right, so now we can go ahead and move forward. Let's go with creating those two teams I talked about. I'm still going to use team A. So I want team A. I just overwrite. You get it. Team A is Michael, Danielle, Braxton, Grayson, Dillard, and Lucille. All right, I do shift enter. So now we have a set that has 6 items in it, as you see up here in the corner. And so now I'm gonna create another set, what I'm gonna call team B. So team B is, let's see, I think to be Sally. You know me, I'm still using those names we've been using since the beginning. So Michael is on team B. Johnny, Braxton is on team B as well. Ken, Jacob, Tony, and Jennifer. Alright, so now we have team A and team B. Team A has 6 members and team B has 8 members, as you can see here. So remember, I said you cannot, you can't index, no indexing with sets, and we'll try it and see what happens. So if I say team A and I try to open up a bracket and put the 0 in it, shift enter, you see it tells you at the bottom, the type error says set object is not subscriptable. That means that it's not subscriptable, means it's not indexable in this situation. You can't use a subscript to roll through it. So an index is considered a subscript, just ensure if you didn't know that. What else you can't do? Also, I want to talk about looping through a set. So you can still do the normal looping that we've been doing for all of them for value in team A. Say we're talking about team A, print out the value, and if we highlight the whole group and then do shift enter, you can get all the items in it, as you see: Michael, Lucille, Grayson, Danielle, Braxton, and Dillard. And another thing too, this can change, this output order could change every single time too, because the computer is not keeping up with its position. So it's all about how it grabbed it from memory. So it's outside the scope of this course. But just know that every time you print this out, it might not be in the same order every single time, every time you load it up. And then you can use the enumerate for val in enumerate team B. I'm going to print val here. And if I'm not mistaken, it should have the little indexes with it. Yep. So Sally, Jennifer, Tony, Jacob, Ken, Michael, Braxton, and Johnny. And now you have the index positions. It's kind of like a little cheat way to get the index, since you can't index it. But honestly, you could have saved this data here as a tuple if you really needed an index, and convert the set to a tuple. Those are different. Just given what you already know, I'm showing you kind of little workarounds you could do if you needed to do that. But yeah, but for the most part, that's pretty much how you those are the only 2 looping places, because you can't loop by index because there is no index. So you can add an index to your data and then maybe save it off that way. All right, the next thing I want to cover before we talk about what makes sets special, which is the ability to do different types of analysis between sets. Let's go ahead and talk about how to look at the membership. The membership system is the same. So if I wanted to see if Michael, let's see, set membership. So if I wanted to see if it's Michael, well, no, let's see if Sally, because she's in one and not the other. If Sally is in team A, it's false, because Sally In team A, she's not in team A. But if Sally is in team B, shift enter, it's true because Sally is actually in team B. So this is a way to see, just like the other data types, container types, to see if an element that you have placed in there is present. You use the set membership to be able to do those things. And again, what if we wanted to add to, say, like for team A, you know, we can't play with 6 and 8 players. That's not fair, right? So we need to add 2 players to team A. There is a function in the set called update. So you just update and then add those people. So for team A, I'm gonna do update. I'm gonna add Rosie. Just making it up. Now Rosie is added to the list. Why did it add? Give me a second. Oh, it did something that I wasn't expected. It broke the word down. I really didn't expect that. So I don't think it's update. Update does something different. I have to kind of go back and look at this, but I don't think this is how you use update. I think what I wanted to use was add. But you know what? Because this problem happened, I will be able to show you a couple things. All right, so I think you can remove. What I'm going to do to use this example, I'm going to remove the capital R, O, S, and Y of Rosie. And we can use this as an example. So to remove those, I think there is a remove. Yep. And I got to do each letter, right? In the right format, because that's what happened. So R, I'm going to do shift enter. See, now it's down to 9. All right, so now I'm going to do the rest of it. O, S, and Y. I did not know that's what that did. So I'm going to do O, S, and Y. I thought update worked like. So with update, we'll get back to it. I think you have to send a list of it in. But anyway, let's finish this. So we do shift enter for the O. That gets it back down to 8. Shift enter for the S, and shift enter for the Y. And now we got it back down to 6 and 8. Now this time, I'm going to put this back here so y'all will see the mistake I made. So I said team A dot update Sally. No, update Rosie. I'm put here, don't do this. Don't do this. What we want to do is update. We want to do team A dot add an element. We want to add Rosie. So shift enter. There we go. So now Rosie is added as a element, and not each one of his letters is added as an element. So now Rosie is what I wanted, and now I want to add one more just to even it up. Let's say team A dot add Ken, I guess. Okay. So what if I wanted to add Rosie and Ken together? That's what the update function is for. So I'm gonna add Rosie and Ken also to the add Rosie and Ken to team A. I'm gonna add them to team B, but then I'm also gonna delete them. I just want to add them so you can see how you can add with the update. So what I would do normally, I would probably do, I want new members. You don't have to do it this way, but I think it's easier just to make sure I can follow myself. New members, and I'm gonna create a list of new members. So that list would be Rosie and Ken. Okay. So I got those as 2 list items. So now what I can do is say team B dot update the way you're supposed to do it. I need to pass in an iterable. So that's now I see why it did what it did. This intakes an iterable. You remember I said iterables are strings, lists, dictionary, tuples, and so what. So what happened was when Rosie got past here, it just iterated line by line for each letter and added the R, the O, the S, the Y, because strings in Python are iterables. I didn't look at this the first time I was watching. This says it takes an iterable, and it's a template. So it takes any type of iterable it's going to add. When you iterate through a list, you get items. When you iterate through a string, you get letters, and that's what happened. So now I'm gonna update new member, new members, and I do shift enter now, and as you see, oh, Ken was already, I like what happened. So I think it's a good example. I tried to update Rosie and Ken, but what if you'll notice is that it was only one update because Rosie was added, and the reason why, remember, sets do not allow duplicates. So when I passed in Ken here, it tried to update it, but it saw Ken was all present, so it didn't need to add Ken, so it only added Rosie. So you have 9 people in the bottom team, 8, and then 8 people in the top team, and we'll just leave it like that. All right, so I think we've covered. So we talked about indexing set. We talked about I like to make sure I keep this clean. How to update a set here, and then we talked about how to add to a set here. Add to a set, and then here we talked about how to remove an element from a set. Okay, so memberships, loops. All right, so the last thing we need to cover is look at the set operations. So before we get started, what I want to do, I want to do a little drawing. So I want to create both teams, and we're gonna do it visually so you can kind of see what it's doing. So the first step, when you create a Venn diagram of a set of 2 sets that you know you're gonna compare, you got to put all the members that are not the same, for that team on one side, and then you do that for the other side. I'm gonna do this in Paint so you can kind of see, and then we can compare the results. So we know we got Michael, Danielle, Braxton, Grayson, Dillard, and Lucille in Team A. Now the first step before I draw it, I need to make sure I know which people are in both. So right now I know Michael is in both, so I can write. I'm just writing that on a piece of paper. Is Danielle in both? Nope. Braxton in both? Yes. Is Grayson in both? Nope. Dillard in both? Nope. And then Lucille. So for this example, it's easy to look at it and draw it, but in real life, I mean, what if these sets were 100 large each? So that would take a lot longer to you wouldn't want to manually check if this was in the set or not. All right, so what I'm gonna do, I'm gonna go to Paint so I can talk about it. All right, so for Team A, we have this circle, and then I'm gonna put the people that are not the same in first. So we know Braxton, and make this smaller. We know, so I can have Lucille over here, and then I got Dillard, then we have Rosie, I'm gonna skip Braxton for now. We have Grayson, then we have Danielle, and then we have who else? Danielle, and then who else? Dillard and Lucille. And Lucille. Okay. Now I'm gonna draw the circle for Team B. Make this big for right now. That crosses these two, like that. And so in this part, this is where I'm gonna put Michael, and Braxton. So, and the reason why they go in the intersection, because this big circle is team A. So they're part of team A, and this big circle is team B. And we know Braxton and Michael are in both teams. So anybody who's in both teams should go here for visual representation, what a set does. So everybody else needs to go to this side. So I'm going to minimize this and write everybody else. So we got Sally. And you got Jennifer. My mouse drawing is getting better, I see, each day. Tony. Jacob. Ken. Oh, I made a mistake. Rosie is in both. I didn't recognize that earlier. Rosie should be here. I'm going to erase her from over there in a minute. Then Michael is already there, and then Braxton is already there. Let me check. Rosie, Ken, this is that issue I was telling you. See how like this is different from this even already, because it's always changing. So I need to bring this up and this up at the same time, just to make sure I've mapped them correctly. Where is it? I need to make this smaller. Move this over. Just trying to get it to where I can just see team B. Here we go. Alright, so we got Braxton, Sally, Tony, Jacob, Rosie, Ken, Jennifer, Michael, and I don't have Johnny. Alright, so this one should have 9 items. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then set 8 should have 8 items. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Why do I have Lucille twice and Dillard twice? Man, making all kinds of mistakes in my drawing. Let me clear this up. That's why you always got to check yourself. Go up here to eraser. Don't need this in here twice. I wish I knew how to make it. So if you wrote that down, trying to follow along, that part is wrong. So we'll do it this way. Alright. Alright, so we got Lucille 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 and 9 on one side. Alright, so this is what I wanted to have set up. So what we have is the intersection, which is this middle area. You have the union, which is everything. And then you have the symmetric differences, which is like how A is different from B will be these names. And then how B is different from A will be these names. And I'll show this. We're going to flip back and forth to this to make sure you understand kind of how the whole set operation thing works. So let me minimize this, minimize this. All right, so let's talk about union. I think that's the one I want to. We're going to call these set operations. That's what the topic is. Set operations. And first we're going to start with union. And what it means, it includes all the values of one instance of each value. So what it's going to do, it's going to look and see. Union tries to take all the data from both groups. Let's go back to the images. So union is going to look at team A and team B, and it's going to return back each name. But if it's a duplicate name, it's only going to return it once. It's not going to return Michael twice, Braxton's twice, and Rosie twice. It's only going to return it one. So it's trying to let you see from both teams who are all the unique team members? That's pretty much what the union is trying to do. So if we go back to the code, there's two ways to do union, and I'm just going to do it. One is using the straight line. I don't forget what the character is called, but it's the same. It's the shift. It's the same key where backslash is. You just hold the shift key down on the Windows keyboard. So it'll be team A. That key looks like a straight line. Team B. This is the union command. So when I do shift enter, what you're gonna get out is a list of all the independent team members. So as you see, Rosie, Michael, and Braxton are only in the list once. They're not in the list more than once. So it's returning back all the unique names in the list. The other way to do this, I'll show you both, or you can do team A, and there's a keyword called union, and it's looking for another set. I know it says iterable, but sets are iterable, but honestly, you normally use this with sets. That's how I've always used it. So when I do shift enter, the results here and the results here should be the same. Even though the order might be different, the results should be the same. Braxton, you know, one everything. So that's what union is. Okay, the next one is, I'm trying to look at my notes, intersection. So intersection, what the intersection is common items in both sets. So for us, the common items in both sets is what here in the intersection. This is the intersection. So it should return Michael, Braxton, and Rosie because they are the three items that are in both the both team sets. So set 1, this entire thing. Set 2 is this entire thing, and they are in both items. So when we go here, let's go back. The intersection. I'm trying to think. I think it's the AND key. So if I do team A and you do the AND sign or ampersand time team B and do shift enter. So it says Braxton, Ken, Michael, and Rosie. So I missed Ken. Is Ken in both sets? Man, there he is there. And there he is there. Yep, my bad. I'm sure if you're watching this video, you probably noticed that along the way. That's the reasons why I believe in letting the code figure it out than me. Yeah, Ken is over here, but Ken isn't over here. 1, 2, 3, 4, 5, 6, 7, 8. So I'm trying to figure out who have I double counted because it's only supposed to be 8. Braxton, Grayson, Danielle, Rosie, Ken. Braxton, Grayson, Danielle, Rosie, Ken. Braxton, Grayson, Danielle, Rosie. That's why I ended up counting twice. I didn't realize Rosie was in 2 spots. So Rosie, I moved Rosie, but then replaced Rosie here. So this shouldn't have been Rosie. This is Ken. Please don't ask me why the tip is so light now. But now, so we have Lucille. Oh, my bad. Ken don't even go here. Oof. Bear with me this video. Ken actually goes here. Okay. Michael, Braxton, Rosie, Ken. And then the other one's on the outside. All right. So again, this represents both the elements that are in both groups, A and B. So we got that correction done. All right. And the other way to do this, I would say, or I like to show you the 2 most common ways. I show you this way because this is not a very common way to do sets, but if you see it this way, you'll know what it means, especially if it's between 2 sets. You'll know what these means. The other way is to just say intersection team B. and it would give you the exact same answer as the and sign. Okay. All right, the next one is they're called symmetric differences. So you're going to return back. I guess I have to show it as an example. So if let me write the thing down. Difference is the operation, and this means well, symmetric difference. I don't want to just say difference. Symmetric difference. Symmetric difference is the set of elements in team A and B, but not in both. So when we do an example, if I say team A dot symmetric difference of team B, you get those names: Danielle, Dillard, Grayson, Jacob, Jennifer, Johnny, Lucille, Sally, and Tony. So it's trying to see in team A, what's the symmetric difference in it. So what names are not in team A? It's kind of what you were trying to say. So for team A, we know if we look at the paint, this is team A. So when I say that for team A, what's the symmetric difference between team B? Well, the symmetric difference for team A to B would be these names: Sally, Jennifer, Tony, Jacob, Ken, and Johnny, if I'm not mistaken. Let's go back. I might be telling you wrong on that. Danielle, Dillard, Grayson, Jacob. Oh, my bad. I got it. I forgot. It's everything but what's in the intersect. Let's go back to paint. So it includes these names like I thought, but also these names. Because these are the names that are not in both. So this is a way to get back everything that's not in both groups. So these are only in team A and only in team B, but they're not in both. So the names should be these four names plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It should be 10 names, right? I just want to verify I got it right. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's saying 9 names. Danielle, Dillard, Grayson, Jacob. Let's minimize this so I can look. So we got Danielle, Dillard, Grayson, Jacob, Jennifer, Johnny, Lucille, Sally, and Tony. Well, I guess I can't count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This has to be 10 names because I said it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah. I must have something. This is crazy. Oh, my bad. I see the problem. It's me again. Ken shouldn't be in here. So that's the problem. Like I say, that first, my biggest mistake was trying to draw this without, real time, without really looking at it. And that's the reason why we use computers, right? To do this, to keep this mistake from happening, where you got two rosters and you're trying to figure it out. Even, I can't even get it correct. And this is a simple roster. It's ridiculous. So now they match. So it is what I thought it was. It's the names that are not in the intersection. That's what the symmetric difference does. I'm trying to think what else that'll be of good information to you. Let's count. I don't want to close it out. I think knowing about two other commands is positive. One is a subset. Let's talk about a subset. So subset, what is if set um, let's say if team A B is said to be the subset of team A. So if team B is said to be the subset of team A, if all elements of team B are true. So what this is saying, say we created a new team, Team C, right? And Team C has, let's do this. Say Team C has Michael, put the quotes, Michael, I'm looking at the team, Dillard and Tony. Literally making this up real time. So no, let's don't do Tony because I think that's going to cause it to be false. Let's do Michael, Dillard, and Rosie. Okay, so this is a new team, Team 3 of 3, right? So you want to know if Team 3 is a subset of A. You can say Team C, that's the team you created. You're trying to say is subset is the question of Team A. And when you do Shift Enter, and the answer is true. Why it's true? It's because the new team, let's go back to Paint. Team C over here has these 3 names, right? Make a circle. What did I say? Michael, Dillard, and Rosie. Okay. All 3 of these members are part of Team A. Michael is here, Dillard is here, and Rose is here. So because this is a subset from this team, it's true because it's saying this new group is part of this group. Now, when I do it for Team B, Michael is true, Rose is true, but Dillard is not. And I think it's going to return false. That's what I was trying to make sure I put an example that would actually return false. So if I say Team C to Team B, it's false, right? And the reason why it's false, go back over to Paint. Michael is present in both. Dillard is not. That's the problem. Rosie is present in Team B. Michael is present in Team B, but Dillard isn't. So therefore, it's false because this sub team doesn't have all the members. It has to have all the members for it to be considered a subset of a team. Okay, and then the last, we're going to talk about subsets. We might as well talk about supersets. So a superset is when, say, if Team B is said, using the formal language, to be the superset of Team A, if all elements of B is true. So, for example, we know Team C is a subset of B, right? That means this makes more sense. Just the reverse of it. So, Team B, we'll just do one example, is a superset. This one is of Team C. This should be true. If one is true, oh no, that's not true. Team B is what did we say? Team C was a superset of A. That means Team A, my bad, I put this wrong. Team A is a superset of C. Yes. So again, it's just the Where's my little paint? It's just a different way of looking at it. So team C is a subset of A, right? Or you could say team A is a superset of C. It's saying that it's the higher order. So like it's a superset. Therefore, this set is from A. But if you're referencing from A's perspective, from A, which is the object that's being referenced here, this might be a little past this, because we're using this object, you're trying to see, does this instant, is it a superset of another instant? So in this way, A is checking to see if they have these items. That check is a superset. Superset. Man, my writing I got terrible now. This is the super part. Super. When I'm team C, which is here, team C is a subset of A. So when team C, because you're using team C as the object, which reference to team C, you're saying team C, go check to see if you're a subset of A. That's what this is saying. So when team when team C has to go make this check, when team C checks to see if it's here, this is subset. So this check is true because team A, C is part, is in here. This is true because team A is the superset of the created smaller team C. Again, like this is one of those things you really got to practice a little bit. If this is your first time seeing sets, it can be a little confusing, and especially if you're not familiar with Venn diagrams, which is what this really is, you just might need to just look at it and make sure you truly understand like what's happening. Again, like the recap for just this, we have two sets, and those set operations are to be able to give you all the unique elements in here, which is union, either or the intersect elements, which is this middle part, or the symmetric differences, which is everything on the outside, like what's not common between the two. Subset and superset is based on how you're referencing it. If you're trying to see if your object is part of another object and it's the smaller one, it's you're trying to see if it's a subset of this, which means that you can find those items inside of here. That's funny. I'm just rambling a little bit. That's the same truth here, except you're looking at it from team's A perspective. So like, don't get confused with the subset, superset. One, because I could say if team B, A is a subset of B. If that was the case, that means all of these items will have to be in B to be a subset. But if I were to say if team B is a superset of A, it'll be the same thing. It's looking to see if all these items are present in B. But if I said if it's a subset of this, it's probably false because team B is not a subset of A. So again, that one you have to play with and practice, and you'll be able to get it. All right, let's do a full recap. This was a good video. I like this one. I'm sorry it was kind of had more mistakes than normal and a little discombobulated, but sets have always been one of the data types that's been a little harder to explain or to get everybody on board with understanding. But in the end, sets are unindexed, unordered collections. They are unique. They don't require a lot of duplicates, and they're immutable. But the set instance isn't. It's mutable. It can be updated. We talked about how to create a set. We talked about the no indexing clause for sets. We talked about how to loop through sets, and then we did set membership to check if that element is within that set or not. Then I went through a whole set of updates, removals, adds, and to show different ways how you can update the mutable set instance. Remember I said the set instance, the team A instance, which is a set, it's mutable. You can change it out, but the elements in it ain't. The elements are not mutable. You can't update those. You have to either remove them and replace it with someone new or not. All right, then we talked about set operations, unions, including all the values of the instance of once, one instance. Then you have the intersection, which is the common items between the two, and then you have the symmetric differences, which is the set of elements in both teams that are not in both. Like what elements are in both teams, but they're not. The elements that are in both teams that are not in both teams. I don't know. That might be just as confusing. And then we had the last section was talking about the difference between a subset and a superset. Okay, so this is the end of this video. I hope you enjoyed it. I hope you to take care, and I hope you enjoy your programming. Until next time.